Hello everybody. So today we are going to see Dijkstras Algorithm for Computer Networks Lab. The program is written in C language. So let us see the instructions. Hash include stdio.h is the standard input-output header file. Hash define infinity 4 nines. This is the macro value that is defined. The name given to this value is infinity with the value of 4 nines. Then max is defined with the value of 10. We are going to define the Dijkstras algorithm in the type of void, where we will initialize a two-dimension array matrix called G with attributes max and max. We need a node n and a variable of start node. We're going to include int main function. Again, we are initializing the G matrix here with the type of int and certain required nodes, namely I, J, N, and U. Next, we are going to write a printf statement to enter the number of vertices required. The value for this will be fetched with the help of a scanf statement for values stored in the variable n. Next, we will enter the adjacency matrix for the number of vertices that we have entered. This adjacency matrix is fetched from the two for loops since the attribute value here is 2. For I is equal to 0, I is less than n, I plus plus. When this for loop turns to be true, then this for loop for j is executed. Once, when both satisfactory values are taken up, the values are read from the scan statement and this variable. Then enter the starting node instruction is popped on the screen where we need to enter which is our desired starting node. And the value is fetched from the variable u, what we have initialized earlier. Then the function of Dijkstras GNU is executed and return 0 is an instruction that returns the value to us. Next, we are going to initialize another void type in Dijkstra that again takes int gmax, int n, and int start node as the previous instruction. Then we are going to initialize a 2D array of int type with the name cost, a distance, and a variable called PRED. Again, a variable with the name visited, count, minimum distance, next node I and j of type integer are initialized. PRED here stores the predecessor of each node. The count gives the number of nodes seen so far. And to create the cost matrix, we initialize two for loops. If the value of the G matrix is equal to 0, then the value of cost matrix is assigned to infinity. If this is not true, then the else statement is executed where the cost matrix is given the value of the G matrix. For initializing the predecessor, distance, and visited variables, we are initializing a for loop and we are assigning distance I with the value of cost of start node of I. The predecessor of I is equal to the start node and the value of visited of I is initially 0. When these three instructions or conditions tend to be true, then distance of start node is given the value of 0, visited or start node is given the value of 1, and count is initialized to 1 as well. When this else condition is executed, the next while condition jumps into taking the value of count to be less than n minus 1. If this value is true, then the minimum distance for the program is set as infinity. The next node variable gives the node at minimum distance. Again, we are initializing a for loop here. If the distance of I is less than the minimum distance and it is a non-visited node, then minimum distance value is the distance of I. The next node is equal to I. To check if a better path exists to the next node, we are writing the set of instructions which say visited of next node is equal to 1. Again, a for loop for I is initiated. If the visited node, then if minimum distance plus cost of next node is less than the distance of I, then distance of I is equal to minimum distance plus the cost of next node. Then the predecessor will take the value of the next node and similarly count is incremented. To print the path and distance of each node, we are going to take a for loop for I is equal to 0, I is less than n, and I plus plus if it is true, and if the value of I is not equal to start node, then the distance of the entered node and its corresponding distance is calculated and the values are fetched from I and distance of I, and the adjacent path is printed. If this is true, then j is equal to I, and a do while loop is executed for the same. When do is j is equal to predecessor of j. If this is true, then the value in j is printed for percentage %d. After the do set of instructions is executed, a while instruction is also executed from the compiler end where j is not equal to the start node. So this is the logic for the Dijkstras algorithm. So let us see the output. To see the output, we need to open the terminal and need to type cc space the file name .c. Once you press enter, the C file is executed. To check the output, you need to type /a.out command. Once you press enter, you can see enter the number of devices. Enter the number of vertices. Once you enter the number of vertices, for suppose say 3, then you need to enter the adjacency matrix. Let me enter some adjacency matrix. So after entering the adjacency matrix, enter the starting node. So let me enter the starting node to be 3. So once you enter the starting node, distance of node 0 is given, the best suitable path is given, distance of node 1 is given, the path for the same, distance of node 2 and the path of the same is printed. So this is for the Dijkstras algorithm in the computer networks laboratory. Thank you.